5 states it has to count. So how many bits are required? 5 states in the sense, yeah, correct. I don't know. Who is that? Who has answered me? Chaitanya. Okay, very good, ma. So 0 to 4 states it has to count. Okay, so 4, binary representation of 4. 2 2s are 4, 0. 2 1s are 2, 0. So 1 0 0. It means that 3 bits are required. 3 bits are required. Okay, so it should start counting from 0 0 0. Okay, then 0 0 1, 0 1 0, 0 1 1. Next 1 0 0. See, I've got 0 0 2, 1 0 0. After this, I should get back my 0 0 back. I should not get 1 0 1. Okay, 101 should not be there. After counting this from 000 to 100, it has to go back to 000. So that is how I need to design the modified ripple counter. Okay, so here first thing is I have got I got to know how many states I have to count. 5 states it has to count. So to count 5 states, I need 3 bits. Okay, then what is the next thing? I need to find out how many flip-flops are required. How many flip-flops are required? So how many flip-flops are required? How many flip-flops are required here?
3.
3 flip-flops are required. Very good. Okay, which flip-flop is required? Which flip-flop is required? Which flip-flop is required to count this? See, again check. Toggling is happening, or do you leave about this last state until here you just check everywhere the toggling is happening, right? And when this is toggling, if this is your Q1, Q2, Q3, okay, Q1, Q2, Q3. So Q1 is toggling continuously. Okay, so which flip-flop is required? Toggle flip-flop, right? Again Q2 is toggling only when Q1 is changing from 1 to 0. Okay, only when Q1 is changing from 1 to 0, this is toggling. In the same way, when Q2 is changing from 1 to 0, this is toggling. So I can use the same structure or same thing whatever I have used before. So I will use 3 toggle flip-flops, and all the toggle inputs I'll give as 1 only, because only when toggle input is 1, it will give the correct output. Correct output in the sense it will toggle the output. Okay, and what I'll do to the first flip-flop, I'll give clock directly, whereas to the with the bubble. Okay, always with bubble. Always with bubble indicates trailing edge triggering. Okay, trailing edge triggering. Okay, so and the output of the first flip-flop is connected as an input to the clock of the second flip-flop. Again Q2, Q3. Okay, the output of the second flip-flop is given as the clock input to the third flip-flop. Okay, so when it gets the clock, the output will continuously toggle. When this gets the clock, when Q1 changes from 1 to 0, this will get the clock. Okay, see again what people are thinking. No, I have drawn this. That's what general mistakes I'm telling you. I've drawn this in the form of clock pulse. They're thinking this is only the clock pulse. No, it is just the connecting wire. Okay, whatever I have done here, it is just the connection between Q1 and Q2. Okay, I can instead of connecting it crossly like this, I have just connected as like this shape of clock. People will think that that is only the clock, and they'll just draw it however they want. So that's the reason I'm just telling you. Okay, so you may ask one more question, ma'am. This circuit and this circuit is same, right? Yes or no, ma'am? This circuit and this circuit is same only. So you told us that this circuit will count from 000 to 111, right? But here I don't want to count all that. Okay, but I just want to count from only 000 to 1. What is it? 100, and when instead of 101, it has to change to 000. Okay, so what I need to do here is I need to do some additional, connect some additional circuit, so that it will count only until 5 states, and then it will go back to 000. Okay, hope my question and my answers are clear to all of you.
Yes, ma'am.
Okay, fine. So now I need to give some additional connections so that this circuit will work as mod 5 counter instead of mod 8 counter. Okay, so if you just observe what is happening after 100, after 100, what is happening? All the outputs are changing to 000. Yes? Yes or no, ma? After the last state, 100 state, what is happening here? Now you just concentrate on these two. What is happening? Whenever I get 100, after 100, the output of the flip-flops, Q1 output, Q2 output, and Q3 outputs are becoming 0. Okay, it means that the flip-flop should be cleared. Okay, so for clearing, what is the option I have? I can give clear input, right? Yes or no? If I make clear is equal to 1, clear value is equal to 1, what happens? Whenever I make clear value is equal to 1, what happens to the output? What happens to the output? Are you feeling it difficult to understand? Then you answer me. Clock CLR is equal to 1. What happens when I make CLR is equal to 1? The outputs will be cleared, right? Clear. CLR is nothing but clear. Whenever CLR value is 1, Q will be equal to 0. Okay, Q will be equal to 0. So when this flip-flop starts counting, see when I give clock input, what happens? It will continuously toggle. The first flip-flop will toggle continuously, and the second flip-flop will change its state when Q1 changes from 1 to 0, and in the same way that third flip-flop will change its value when Q2 changes from 1 to 0. Okay, but after this state, see, until this state it is fine. Okay, first see, initially I'll make all the clock is equal to I know I'll not give any clock, but I'll make all the flip-flops outputs to 0. Okay, now what I'll do, I'll give the first clock so that my output will change to 001. Next again I'll give one more clock, it will change to 010. Again I'll give one more clock, it will change to 011. Again I'll give one more clock, it will change to 100. But after this again, even if I give the clock, it should not change to 101 because it has to just count only until mod 5. In the sense, it has to count only from 0 to 4. Okay, after that it should come back to the normal to the first state, which is nothing but 000 state. Okay, so what is happening here? I need to do something. I have to give I have to say this clear input that after this it has to get 1 as its value. After this state only it should get 1. Okay, after this state only it should get 1. Okay, so only when this state gets 1, after this state the CLR value is made 1, then the output will turn to 000. So in order to do that, instead of 101, I need to get this 000. So for that, what I'll do is, see, 101 in the sense Q1, Q2, Q3. Okay, so what is happening here? Q1 is 1 and Q3 is 1. Okay, so what I'll do, I'll take Q1, just let me connect the circuit first and then I'll explain you. So Q1 I have taken and also Q3. Q3 I have taken and I've given it to AND gate. AND gate. Okay, I'll give it to AND gate. AND gate. So from this AND gate, I'll give it to the all CLRs together. Okay, so what happens here? Let us check. Okay, so in all the cases, this output of this AND gate will be equal to 0 because see, just check all the last for Q1 and Q3. So Q1 is 0 and Q3 is 0. So 0, 0, the output will be equal to 0 only. So this CLR output, the AND gate output will be equal to 0. So that 0 will be given to all the CLR values. So it will not affect. Okay, then next 0, 1. Okay, 0, 1, 0, 1, the output of the AND gate will be equal to 0 only. Okay, so still clear is not equal to 1, so it will not affect. So 0, 0 again. The next state here 0, 0. If you check here, Q3 is 0, Q1 is 0. That is given to the AND gate. The output will be equal to still 0. Next again 0 1 1 0 sorry 0 1 1. Okay, so 0 1 1 0 and 1. Okay, ANDing this 0 and 1, the output will be still 0 only. Next 1 0 1 0 1 0 1 0. The ANDing will be equal to AND gate output will be equal to 0 only. Next after this it has to give me 1 0 1. Now if you check, Q3 is 1 and Q1 is 1. Okay, so what happens? It will not give me this state, and see this Q3 and Q1 is connected to this AND gate. So 1 1, the output of this will become 1. Okay, so this 1 is given to the clear input. So whenever I give the clear input, what happens? It will clear to 0. So I'll not get 1 0 1 state. Instead, it will go back to 0 0 0. Is this clear? Is this clear? Is my explanation clear to all of you? Anybody have any doubts? Please let me know. Okay, so here what I have done is I have used an additional gate. Okay, which is nothing but the AND gate I have used, and to the AND gate I have connected Q1 and Q3 together to that. Okay, because just by saying this I have written 1 0 1 1 0 1, in the sense this is my Q3 value and this is my Q1 value, right? So Q1 value is 1 and Q3 value is 1. Only in this case I have 1 1. Rest all it is not 1 1. Okay, so that is the reason what I thought. If I give Q1 and Q3 to the AND gate, only when Q1 and Q3 is 1, the output will be equal to 1, and the clear input it will get as 1 1. Okay, whenever the clear input, if the flip-flops get clear input as 1, then immediately it will turn the outputs to 0 0 0. Okay, so that is what will happen. Okay, so that is the reason I have connected Q1 and Q3. Apart from this 1 0 1, rest all cases the output of the AND gate will be equal to 0. Only when it tends to 1 0 1, okay, immediately what happens, this gate output, this AND gate output will become 0, and it will be given to all the flip-flops. Okay, all the flip-flops, so that it will clear the output. So instead of 1 0 1, it will count back as 0 0 0 only. Okay, so after this 1 0 0 we'll get 0 0 0, and then it will continue. Okay, so this is the design, but generally instead of having this is said to be the active high input. If I'm giving directly 1 to this, it is said to be the active high input. Active high input, in the sense the flip-flop will work when I give high 1 as its input. Okay, you can just trigger the flip-flop just by giving active low input. Active low input. So whenever we'll go with the active low input, what we need to do is we need to use a bubble. Okay, you need to use the bubble. Okay, so bubble in the sense what I'll do here, it should have the bubble. Okay, everywhere. Okay, bubble in the sense it has to get 1 as value, so it means that the input here should be 0. The input should be 0. Only when the input at this bubble is equal to 0, the clear input will be equal to 1. This is said to be active low input. Active low in the sense whenever you give the low inputs, the triggering will happen. Okay, that is what it means. Okay, so since I have to get 0 here, which flip-flop I need to use here? Sorry, which gate I need to use here instead of AND gate? I cannot use AND gate now. I cannot use AND gate now. Instead of AND gate, I need to use some other gate. Which gate I should use? Can anybody try? I need to get 0. Okay, whenever Q1 and Q3 is changing to 1 1. Okay, I will only tell you. I'll use one NAND gate. So easy way to just take this is, here if I'm putting a bubble, here also you can put a bubble. That's all. Okay, so just check again. So what is the truth table of AND gate? Let me write the truth table of AND gate. Let me write the truth table of AND gate. Sorry, NAND gate. 0 0 0 1 1 0 1 1. Okay, so NAND gate output, where will you have 1 and where will you have 0? Oh, sorry, where will you have 1 and where will you have 0? Only in the last case you'll have 0 and all others it will be 1. Okay, so if you just take all the cases, all the inputs, Q3, Q1, both are 0, 0. So 0, 0, the output of this AND gate will be 1. 0, 1, the output of this AND gate will be still 1. 0, 0, the output of this AND gate will be still 1 only. The 0, 1, the output of this AND gate will be still 1 only. 1, 0, the output of this AND gate will be 1 only. Okay, after this 1, 0, 0, the next state is 1, 0, 1. Okay, so what happens here, as soon as this 1, 0, 1 comes, your Q3 is 1 and Q1 is 1. So 1, 1, 1, 1, the output here will be equal to 0. That 0 will be fed to all the CLR through the bubble. Okay, so since I have the bubble, it will invert, so my CLR value will become 1. Okay, so generally practically we'll have the active low inputs only. Okay, so we need to connect active low inputs only, so that is the reason here also it is the same thing. Okay, so instead of using AND gate, you just use an AND gate and a bubble here. So this is all related to your mod 5 counter. Anybody have doubts here, please let me know. Otherwise, I'll go with the next one. Is this clear to all of you? Anybody has any doubts here? Everybody else in the class? Yashwant? Any doubts you have here?
No, ma'am.
Grishma? Grishma Muniraj? Are you understanding?
Yes, ma'am.
Okay, fine. So what I'll do today, I'll give questions related to ripple counter and counters as an assignment. Okay, I've already posted quiz also. You people can attempt those that quiz. Okay, today only immediately after my class you can attempt that and you can become free later. Okay, so attempt that quiz compulsorily. Okay, and as I've already mentioned, quiz will also carry the marks. Okay, so this is what all related to the asynchronous counters. Okay, even this is nothing but the asynchronous counter. Okay, so even this is nothing but your asynchronous counter. Now we'll go with the next one, synchronous counter. Okay, here the designing part will be a little different because here synchronous counter. So as I've already mentioned, in the synchronous counter, we will give clock pulse simultaneously to all the flip-flops. Okay, so here specifically synchronous counter, you have mod 16 counter. So again, mod 16 counter, you tell me how many flip-flops you need to use. I'm not going to help you. You should only tell me now how many flip-flops are required. How many bits are required? How many flip-flops are required? Tell me that.
4 bits.
4 bits are required. So 4 flip-flops are required, right? Everybody is getting this answer. Yes. Either synchronous or asynchronous, don't mind. Okay, so in synchronous also we'll use the flip-flops, in the asynchronous also we'll use the flip-flops only, but only difference is there will not give clock simultaneously, but here we'll give clock simultaneously. Okay, so that is what the difference. Okay, so here mod 16 counter, in the sense it has to count all the states from 0 to 15. Okay, 0 to 15 in the sense 0, 0, 0, 0. Okay, so 0 to 15. So in order to represent 15, you need 4 bits. Okay, 4 bits, 1, 1, 1, 1. Okay, 4 bits are required. So mod 16 counter has to count from 0, 0, 0, 0 to 1, 1, 1, 1. After this 1, 1, 1, 1, it has to go back to 0, 0, 0, 0. That is how you need to design this counter. Okay, so here, as I've mentioned, since you're giving, see, in the previous case it was different. Okay, how it was, you try to design mod 16 ripple counter. Okay, just try. Okay, mod 16 ripple counter, how you have to design, you just check. Okay, that is like higher order thinking. In the higher order thinking, you can use this mod 16 counter. I have not taught you. You need to just think about it. Mod 16 ripple counter. All of you please try this problem. Mod 16 ripple counter. Okay, mod 16 ripple counter. In the same way, you can even try mod 5. Just now I've shown you mod 5. In the same way, you just try with mod 6 counter also. Okay, mod 6 counter also. Just try these two questions. Everybody in the class, try mod 16 counter and mod 6 counter. And those two are ripple counters only, asynchronous counters. Okay, so coming to this synchronous counters, as I've already mentioned, it will have all the clock pulses given together. Okay, so here I need 4 bits to represent to count the 16 states. So I need 4 flip-flops. Okay, so in the exam, they may ask the question as mod 16 counter, or they may ask as 4-bit synchronous counter. Synchronous counter. Either ways they can ask you the question. Okay, they may either give mod 16 synchronous counter or 4-bit synchronous counter. Anything they give, you need to design it. Okay, so now we'll just see the design steps. Before going for the design steps, as I've mentioned already, we will do the analysis here. Okay, so first what it has to do, it is having 4 flip-flops, so I'll have 4 outputs: Q3, Q2, Q1, Q0. 4 outputs. Each flip-flop will have Q0 output, Q1 output, Q2 output, and Q3 output. Okay, so now initially what I'll do, same. I will just see, it has to count from mod 16 counter. It has to count from 00 to 1111. So initially what I'll do, I will give clock clear is equal to 0, so that all the flip-flops will be equal to clear is equal to 1, so that all the flip-flop output will be equal to 0. So initial state of the flip-flop is 0 0 0. Okay, without giving any clock pulse, without giving any clock pulse. Initially I am making all the flip-flop outputs to be 0. Okay, then after this, what is the next state? After this state, I have to get as 0 0 0 1. Next is 0 0 1 0. Next is 0 0 1 1. All of you make a note, write along with me. All the states I'm writing here, that's it. Next one is 0 1 0 0. Next one is 0 1 0 1. Next one is 0 1 1 0. Okay, next state is 0 1 1 1. Next state is 1 0 0 0. Okay, next is 1 0 0 1. Next is 1 0 1 0. Next is 1 0 1 1. Next is 1 1 0 0. Next is 1 1 0 1. Okay. After this, the next state is 1 1 1 0. After this, the last state is 1 1 1 1. After this state, what it has to happen? It has to go back to 0 0 0 0. Any doubts in this representation? Please let me know. Okay. Now, okay. As I've mentioned, you need 4 flip-flops. Okay. So again, here also I'll just take toggle flip-flop only. Okay, let me increase the size. Let me take toggle flip-flop only. Because here also toggling is happening. Here also toggling is happening. Okay, so if you just check one state with the next state, toggling is only happening. Okay, but the toggling way is different. The approach to design this should be different. Otherwise, here also toggling is happening. If you just take Q0, Q0 is toggling continuously. Q1 is also toggling after 2 states. Okay, 0 0, then it is toggling. Okay, so here also I'll just use toggle flip-flops itself. Okay, so 4 toggle flip-flops I'll use. Okay, and here since it is synchronous counter, what I need to do, I need to provide clock simultaneously. It is not like before. Like asynchronous, what we did, we have converted the output of one flip-flop as the input to the other flip-flop. But here I should not do that. Synchronous in the sense I have to provide clock simultaneously. I need to provide clock simultaneously only. And here I need to this is my clock. Clock is provided simultaneously. Everywhere I'm using T flip-flop only. Let me name this as T0, T1, T2, T3. How I've represented here? See, always know this Q0 corresponds to T0, Q1 corresponds to T1, Q2 corresponds to T2, Q3 corresponds to T3. Okay, and here whenever you're reading the output from the counter, read from right to left. Okay, right to left. So this is my Q2, this is Q1, this is Q0. Okay, and this is Q3. Okay, so as I've already mentioned, read it from left to right. 0 0 0 0, next to 0 0 0 1, like that. Okay, read it from right to left. That will give you the correct operation of the counter. Okay, fine. So now see, initially I'll make all the Q0, Q1, Q2, Q3 as 0. Okay, but 0 0 0 0. Okay, this is the first thing. Let me think that I have reset the flip-flops. Okay, now only this flip-flop should toggle. Only the first flip-flop should toggle. What is that? This flip-flop should toggle. So I'll get 0 0 0 1. Okay, in the next case, this should toggle and even this should toggle. What is the next state? 0 0 1 0. So this also should toggle and this also should toggle. Okay, so in different times, different flip-flops has to toggle. Okay, and whereas the first flip-flop has to toggle continuously. So for this you can give 1, no problem. For this you can just connect 1. But what about the others? Okay, we don't know what input should be given to T1, T2, T3. Okay, even to T1 also we'll just design. I'll show you the design steps, don't worry. But here what I want to show is, what I want to tell you is, see, based on some T0 input only, because here I'm giving clock simultaneously, in the sense whenever the clock is given as what is that, trailing edge trigger here, trailing edge trigger here, trailing edge trigger here, trailing edge trigger here together, it will check for the inputs. What are the inputs here? T1, T0, T2, T3 are the inputs. So it will check its inputs, and based on that inputs, it will decide whether the output of that particular flip-flop should be toggled or not. Okay, so I'll just show you the design. How you need to design is, so here you need to get the connections for T0, T1, T2, T3. Okay, so for that, let us go back to the table. Here I'll write as, wait, let me erase this. Are you all following?
Yes, ma'am.
Okay, so I'll just take as T3, T2, T1, T0. Okay, so it has to change its state from 0 0 0 to 0 0 1. Okay, so if it has to change from 0 0 0 0 to 0 0 0 1, we will find out what should be the values of T3, T2, T1, T0. Okay, that is what I'm doing. So every step, first I'll take these two and I'll find out what should be the inputs here. In the same way, next I'll take these two and I'll find out what should be the values of T3, T2, T1, T0, so that this will toggle. Okay, that is how we proceed. Let me just write it. Okay, so first I'll take, this is my initial state. Okay, so now I need to give some inputs to this T3, T2, T1, T0, so that my output will change from 0 0 0 0 to 0 0 0 1. Okay, so first of all, you just check Q3. Does it toggle? Q3 has toggled or not? This is the present state, ma. So I need to get next state as 0 0 0 1. Okay, if I want to get 0 0 0 1, what should be the values of T3, T2, T1, T0, so that my next state will be this one. That is what my thing. Okay, so for that I have to have the entries for T3, T2, T1, T0. So I'm asking you T3 is nothing but the input to this last flip flop. T3 is nothing but the input to this last flip flop. Okay, so I'm asking whether this is toggling or not. Is it toggling? Toggling in the sense, is it changing its state?
No, ma'am.
No. So what should be the input to T3?
0.
See, I'll come. Yeah, it's right. I'll come again. 0, 0, 0, 0 is my present state. Now I need to get 0, 0, 0, 1 as my next state. Okay. So since this is not toggling, see, if it is 0, the next state is also 0 only. Okay. If the present state is 0, the next state is also 0. So what should be the input here? It should be 0, right? If it is 1, it will toggle, right? Yes or no, ma? If my T3 input is 1, what happens to the output? It will toggle, right? Yes or no, ma? Okay, fine. See the truth table only and tell me. Okay, so 0, 0. So toggling is not happening, in the sense the T3 input should be 0 only. 0, 0. Toggling is happening. Are you understanding what I'm trying to say here? My question is it toggling?
No, ma'am.
No. So what should be the input to T2?
0 only.
0. Okay, Q1, the present state is 0, the next state is also 0. Is it toggling?
No, ma'am.
So it is 0. What about Q0? Is it
Yes.
toggling? So what should be the input?
1.
1. Very good. Okay, so I'll just come back to the diagram again. I'll come back to the diagram again. See. Now my present state is 0, 0, 0, 0. Okay, so the toggle inputs are for T3 it is 0, only for T0 it is 1. Okay, T0 it is 1 and rest all it is 0. Rest all inputs are 0. So what happens? Q0, T0 is 1 and it is also getting the clock signal. So what happens to the output? Output, the present state is 0. So what will be the next state? Clock is there, T0 is 1. So what happens to the output? Q0, will it, this is a present state. So I want you to say what will be the next state. It will be 0 or 1. It will not be 0, no. See, the toggle input is 1 and I'm getting the clock also. So it will toggle, no. If the present state is 0, the next state will be equal to 1. I don't know why you're getting confused. 1. Okay, again, now clock is there, T1 value is 0. So will it toggle? What is the truth table of your T flip-flop? If I give a 0, your Qn plus 1 will be equal to Qn only. If T value is 1, your Qn plus 1 is Qn bar. Okay, Qn is nothing but the present state. Qn bar is nothing but the complement of the present state. So here if you observe, the present state is 0 and T0 is 1 and clock is also there. Okay, so what happens to the output? It will toggle. Okay, take the second flip-flop. T1 input is 0 and the present state is 0. Okay, so T1 clock is also there. T1 T input is 0 and the present state is 0. Okay, and clock is also there. So what will be the next state? It will be Qn only. Qn in the sense present state. Whatever present state was there, the same thing will be in the next state also. Here also T2 is 0. So the next state will also be equal to 0 only. Clock everywhere. See, again and again I will not speak about clock. Clock is given simultaneously to all the flip-flops together. Okay, so I'll just check the input. T2 input only I'll check. So T2 input is 0. So the output will not toggle. It will change. It will remain in the same state. So 0. So now T3 is equal to 0. So the output will not toggle. It will remain in the same state. Okay. So if I give my T3, T2, T1, T0 inputs like this, I'll get the next state. In the same way, let me just check here. Now after this, when I give this, my next state will be this one. Okay, now again, what should be the inputs to T3, T2, T1, T0, so that it will change to 0, 0, 1, 0. So just check Q3. Q3 is 0, the present state is now it is in the present state of 0, 0, 0, 1. When I give this inputs, my the present state is changing to 0, 0, 0, 1. Okay, now I need to get 0, 0, 1, 0. So what I need to do, what inputs I should give to T3, T2, T1, T0, so that it will change from 0, 0, 0, 1 to 0, 0, 1, 0. Okay, so just check Q3. Q3, is it toggling? Q3 is toggling or not? Quickly, somebody please keep your mic unmute only. I want answers from you.
No, ma'am.
No, so it will be equal to 0. Next, Q2. Q2, is it toggling?
No,
So what will be the input to T2?
0.
0. What about Q1? Is it toggling?
So it's 1, ma'am.
It's toggling, so T1 will be 1. This one, Q0, is it toggling?
Yes, ma'am.
Okay, it will be 1.
0.
Okay. No, it should be 1. 1 to 0, it is changing. No toggling is happening. So T input will be 1. Only when T input is equal to 1, according to the truth table, only when T input is equal to 1, only when T input is equal to 1, the output will toggle. Okay, fine. Next. So when I give this in T1, T2, T3, T4, sorry, T0, T1, T2, T3 as dis inputs, my flip-flop will change to next state as 0, 0, 1, 0. Okay, now again, now the present state is this one. I need to get the next state. In the sense, I need to compare with the next one. So what input I should give to T3, T2, T1, T0, so that I'll get 0, 0, 1, 1. Okay, so Q3, no toggling, so 0. 0, 0, no toggling, so 0. So 1, 1, no toggling, so it should be 0. Input should be 0. T1 input should be 0. 0, 1, toggling is happening, so the input will be 1. Okay, hope you are understanding. Anybody is getting any doubt anywhere, please let me know. Okay, so now when I give this inputs and the present state is this, and then when I give this inputs, it will change to the output of the flip-flops will change to 0, 0, 1, 1. Okay, now I need to again find out what inputs should be given to T3, T2, T1 and T0, so that it will change from this state to this state. Okay, so just observe these two. No toggling. Toggling is happening, so T input will be 1. Again here also toggling is happening, so input is 1. Again here also toggling is happening, so input is 1. Okay, so next, this is how you need to fill the table. Okay, next, I have the present state as this. When I give this inputs, my present state will be this one. Okay, now now again I need to give some inputs, so that it will change to 0, 1, 0, 1. Okay, so 0, 0, no change, so this will be equal to 0. 1, 1, no change, 0. 0, 0, no change, 0. 0, 1, it is toggling, so this input is 1. Okay, next, my present state is this, so I need to give some t values, so that it will change to 0, 1, 1, 0. These two, no change, so 0. 1, 1, no change, 0. 0, 1, toggling is happening, so 1. 1, 0, toggling is happening, 1. Okay, so this is the next entry. In this way, you need to fill the complete table. Okay, so now when I give 0, 0, 1, 1 as inputs to T, all the T flip-flops, so the present state will be this one. Now I need to get this state 0, 1, 1, 1. Okay, so just check the inputs, outputs. No toggle, so 0. No toggle, 0. 1, 1, no toggle, 0. 0, 1, toggling is happening, 1. Okay, next, these two you need to compare. These two you need to compare. So 0, 1, toggling is happening, so 1. 1, 0, toggling is happening, so 1. 1, 0, toggling is happening, so 1. 1, 0, toggling is happening, so 1. Okay. Next, again you check. Write along with me. All of you please write along with me. 1, 1, no toggling, 0. 0, 0, no toggling, 0. 0, 0, no toggling, 0. 0, 1, toggling is happening, so 1. Okay. You need not write this arrow marks. Okay, I'm writing you only to explain you. Next, the present state is this 1 1, no toggle 0, 0 0, 0 0, no toggle 0, 0 1, toggling is happening 1, 1 0, toggling is happening so 1. Okay, next. So 1 0 1 0, so 1 1, no toggling 0, 0 0, no toggling 0, 1 1, no toggling 0, 0 1, toggling 1. So again these two, 1 1, no toggling 0, 0 1, toggling is happening 1, 1 0, toggling is happening so 1, 1 0, toggling is happening so 1. Next, 1 1, toggling, no toggle 0, 1 1, no toggle 0, 0 0, no toggle 0, 0 1, toggling is happening 1. Can you try to fill this table? Rest all. Everybody try this.
Yes, ma'am.
Okay, fill this table and tell me the entry. I'll give you little time, because no, my intention here is it should be always two-way communication. That is the first thing I want to make sure. And the second thing is, only when you start thinking, your brain will get activated. And the two online classes, you like if you are simply listening, no, nothing will go to your head. Only when you are actively participating, it will go to your head. That is the main reason. Like again and again, I'll be asking you the questions. Anybody has got entry for this here? I'll call somebody. Aishwarya Raju. Aishwarya Raju. Aishwarya. Okay, fine. Anybody rest, because no, I am already lagging with the time. Okay, anybody has got this entry here? Tell me, ma.
0 0 1 1.
Very good. See, no change, 0 0. Again, no change, 0. 0 1 changes there, so 1. 1 0 changes there, 1. Very good. Who is this?
I'm Geeta.
Very good, ma. Okay, next. Again, the entries here. Just check the entries here. Tell me the entries here.
0 0 0 1.
0 0 0 1. Very good. Next.
1 1 1 1.
That's all. Okay. Hope you have understood how to write the truth table. Okay. So from this we need to design now. Okay. Design now in the sense like we need to take the equations. See, now the outputs designing in the sense these are nothing but the outputs T3, T2, T1, T0. Okay, so what should be connected to this T3, T2, T1, T0, so that it will work accordingly. Work accordingly in the sense if the present state is 0 0 0, the next state should change to 0 0 0 1. If this is the present state, next state should change to 0 0 1 0, like that. Okay, so in order to do that, what we have to do is we have to write the equations for T3, T2, T1, T0. T1, T0. Okay, first you need to write the equations. Okay, so T3 equation. Can anybody tell me the T3 equation? T3 equation. T3. See, Q. Here only I have one. See, same, the logic of writing the output equation will not change. T3 equation you need to write. So here I have one. So its corresponding values I need to write. Okay, so what is that? What is the corresponding values? Q3 bar, Q3 bar, Q2, Q1, Q0 plus. Again you check for ones, only in the last here I have one, so its corresponding input, so it is nothing but Q3, Q2, Q1, Q0. So That's all. No, T3 equation is only that much. Okay, so T3 will be equal to, here what I can do, I can take Q2, Q1, Q0 as common, so that I'll be left out with Q3 bar plus Q3. Q3 bar plus Q3 is nothing but 1, so I'll be left out with Q2, Q1, Q0. Okay, so what I need to do, to this T3, I need to give input as input from input from Q2, Q1, Q0, in the sense like take all, what is it, Q2, Q0, Q1, and then Q2, and operation between all these three. Okay, so that I'll get Q2, Q1, Q0, give it to T3. So whenever Q0, based on Q0, Q1, Q3, Q2 values, this T3 will change, and if based on this T3, if T3 value is 0, this will trigger. If Q3, no, it will not trigger, it will remain in the same state. If T3 is 1, then this will trigger. Okay, if it is 0, it will change to 1. If it is 1, it will change to 0. Okay, it toggles. So so you got equation for T3. In the same way, you need to get equation for T2, T1, T0 also. Okay, so when time permits, I'll explain you the simplification. Okay, see, can somebody tell me the T2 equation? Somebody tell me T2 equation. T2 equation. T2 equation quickly. I'm thinking that all of you are writing the equations. Q3 bar, writing everything. So if you just observe 0, 1, 2, 3, third, when it is 0, 0, 1, 1, the T2 output is 1, right? Have you all noted down the table?
Please call the table.
What, ma?
The table, ma'am.
You want to see the table?
No, ma'am, I have to take down that.
Take down?
I have not moved down.
Okay. So you want to note it down right now? Wait, let me just reduce it. Could you see the table properly?
Yes, ma'am.
Okay. Quickly write the table. Those who all want to copy the table, you can copy. Otherwise, what you can do is you can just leave it. I will only give you the equations. Don't worry. You try to fill the table on your own. Only then you'll understand like where exactly you're going wrong or whatever your understanding is right. Okay. Will you write on your own later?
Yes, ma'am.
Okay. Try to write on your own later. Let me just write the equations. So T2 is equal to Q3 bar, Q2 bar, Q1, Q0, okay, and then plus Q3 bar, Q3 bar, Q3 bar, Q2, Q1, Q0, plus here you have got 4 terms. Next is Q3, Q2 bar, Q1, Q0, plus Q3, Q2, Q1, Q0. Okay, so this is the equation for your T2. Okay, so here you can simplify this. Okay, so when you simplify this now, you try to simplify using Boolean algebra. You can do it easily. Using Boolean algebra, try to simplify this expression. You'll get T2 as Q1 and Q0. Okay, in the same way you need to write equation for T3 as well. Okay, so T3, instead of writing not T2, no, what is that? T2, T1. For T1 also you write the equation. Okay. I hope everybody knows how to write the equation, right?
Yes.
Okay, so write T1 equation. So you'll get 8 terms here. So all that terms, see, you have plus symbol in between, right? So those are said to be the sum of products. Okay, so that can be given as summation, sum of products. Okay, these all, see, it is nothing but addition, sum of all the product terms, right? Sum of products can be generally denoted as summation. Okay, and if you just observe, this value is equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 15. So if you try to write its output equation, it will be summation 1. Okay, it's complete. Where is that? Here I've got 1, right? So the decimal equivalent of this binary number is 1. In the same way, the decimal equivalent of this is nothing but 3. Okay, in the same way, the decimal equivalent of this is nothing but 5. So if you try to write the equation, it will be like summation. Wherever you have 1, that should be written in the equation. So it will be 1, 3, 5, 7, 9, 11, 13 and 15. In all these places you'll have 1. Okay, and sum of products can be generally represented as summation like this. Okay, so when you simplify this, you'll get as Q naught. Okay, you will get this equation as Q naught. In the same way, I have to write for T naught also. T naught, if you just observe, as I've already mentioned, it will toggle for all the inputs. Okay, for all the inputs, it has to toggle. So if you check the table, everywhere T naught value is 1 only. Okay, so if you just try to write the equation for this, T naught will be equal to summation of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the equation for your T naught. Okay, so if you observe, you have so many terms. See, if it was only 2 terms, no, we could easily do it, or even 4 was also fine. You can simplify this using Boolean algebra. But as the number of terms increases, it will become very tedious to use Boolean algebra. So in that case, we'll not use Boolean algebra. Instead, we'll use K-map method. So I'll show you this method if time permits. Otherwise, it is not required for you. You'll study it in your next semester. Okay, you'll study this in this K-map in the next semester. But here, what you need to do is you have to just remember the equations. T naught. When you simplify this, you'll get as 1. Okay, when you simplify this complete equation, you'll get as Q naught. Okay, this many terms will reduce to Q naught. This many terms, it will just reduce to 1. Okay, so here you need not, even in the exam, you need not simplify everything. But what you can do is you have to write write about mod 16 counter, how many flip-flops are required, how many bits are required, then write this truth table. Then finally, on simplification, we'll get T3 as Q2, Q1, Q naught, and T2 as Q1, Q naught, and T1 as Q naught alone, and T naught is 1. Okay, so this equation directly you can write. Okay, so it is not too tough to remember. T naught is 1, T1 is like you will just have Q naught. Okay, T2 is Q1, Q naught, T3 is Q2, Q1, Q naught. Okay, now you need to implement it. Okay, implement in the sense whatever circuit I have drawn here, to this you need to make the connections. Let me just erase this. I'll show you this K-map by taking some time later. Okay, not now immediately, because it is a time-taking process. Because if I have to go with 4 map, I need to start from 2 map, 3 map, 2 variable K-map, 3 variable K-map. Then I have to come back to 4 variable K-map. Okay, so that's why I'll not do that. That's what, whenever time permits, I'll do, or like I'll just show you how I've done. Okay, fine. So Q now will start connecting. So as I've already mentioned, T naught will get 1 as its input, T1 input is nothing but Q0, so just give Q0 to T1. And then T2 is nothing but T2 is Q0 and Q1, so connect Q0 and Q1 to the AND gate and give it to this T2. So the output here is nothing but Q0 Q1 is given to T2. Okay, fine. Now T3 inputs are Q0 Q1 Q2. Okay, so what I can do here, I have already got Q0 Q1. So now what I'll do, I'll take one more Q2 from here and connect it to the AND gate and then connect it to T3, so that the output, this is Q2 and the output here will be Q0 Q1 Q2. Okay, that is given to T3. Okay, so if the connections are made like this, it will work as counter. Okay, so this is the design of your mod 16 ripple counter. Okay, is this clear? Hope you all understood. Okay, that's what, as I've already mentioned, don't worry about the simplification, but you just try to simplify this expression using Boolean algebra. Okay, now let me just open my notes and show you the K-map simplification. I'll just show you. This is a K-map simplification. So whenever you have more number of terms, you'll not be able to simplify. It becomes tedious. It is not that you'll not be able to, but it will become tedious to simplify using Boolean algebra. So in that case, we'll go with the K-map method. Okay, so K-map method, in the sense you need to represent it in this square form. Okay, in this square form, then based on the entries we'll just map together, and then based on the mapping you'll write the output. Okay, so this is your K-map. Okay, so I'll definitely teach you K-map, but not now, immediately. Okay, so this is a K-map method. With this K-map method only I can directly get Q0 Q1. Okay, then T1 is when you simplify this entire thing, this is nothing but the mapping. Okay, so T1 will be Q0. Here all the entries, the complete K-map will have 1 as the entry, so it will be equal to, the complete thing will be will overlap each other, so T0 will be equal to 1. Okay, so now if I say no, you will not understand how from this I have written T1 is equal to Q0 and all. Okay, let me just teach you separately on K-map. One day I'll definitely teach you K-map, but right now it is not that important to know. Okay, because that is not there in your syllabus also, and like you don't need it for your exam also. Okay, so if you write it, it is well and good, but otherwise also you can directly write the equations. Okay. Hope this is clear to all of you. So this is the final design. Okay, so this is the design circuitry. See, Q0, Q1, Q2, Q3, Q2 to Q3 to T3. I've given Q0, Q1, Q2 as inputs. T2 I've given Q0 and Q1. T1 I've given Q0. Directly Q0 is given. Okay, so where is that? And everywhere you need to take the output. Q0 output, Q1 output, Q2 output, Q3 output, Q0 output, Q1, Q2, Q3. Okay, see, now I'll give you 3 questions. I'll not upload it in the Teams, because if few people are not able to do that, then unnecessarily they'll lose marks. So what I'll do, I'll you just do it offline in the sense, like do it in your notebook and send me personally. Okay, not in Teams. I don't want it in Teams. Okay, so try to implement mod 16. It is not there in the syllabus. This is out of the syllabus. I'm telling you. Mod 16. See, asynchronous counters, mod 16 you design, and also mod 6. And synchronous, I'll just give you the lower order, mod 8 counter. Design this mod 8 counter as well. Okay, design this and send me the WhatsApp message. Scan it and send me the WhatsApp message. Okay, this won't be asked in the exam. Okay, so in order to make you understand the concepts clearly. I'm just asking you to do it, to implement it. Okay, fine. That's all for now. You have two more theory topics that I'll finish, and I'll also give you the introduction on Monday, introduction to the first module. Okay, most of the things, most of you know very well, like what is atomic weight, atomic number, electrons, holes, nucleus, everything you people know. I'll just brush up everything. Okay. That's all for now. And you people attend the quiz now itself in front of me, and then you can leave. Anyway, afternoon you people are free only, no? Like Andre, like you don't have any classes, so please finish the quiz now itself in front of me, and you can tell me and leave. Okay. Hope whatever applications have taught you, it's clear. Hmm? All the applications are clear, whatever I've taught you. Hmm? Answer me.
Yes, ma'am.
Everybody else, rest in the class. Hardly I could hear 3 to 4 voices, that's it. Maximum to maximum 10 voices, not more than that. Is it that you're not understanding or you don't want to say? Okay, quickly attempt the quiz. If anybody is getting any doubts anywhere, please tell me. Anybody has finished the assignment? Sorry, quiz? Still doing?
Yes, ma'am. Done.
Done, you can leave, ma. Okay, fine. You people, I don't know, many people have already left in spite of me telling. People have already left. Okay, leave. I don't want to force you people also to stay back. Just you can also leave the group, but make sure that you attempt the quiz by tomorrow.
Thank you.